Hi guys, so welcome back to 11.2. This is talking about recursive formulas for arithmetic sequence. So hopefully, as we all know from the last section, a recursive formula is a formula where you use the previous term to find the next term. So with arithmetic sequences, this is really easy. You're just taking the previous term and you're adding that common difference. And we say n is greater than or equal to 2 because if n is 1, then the previous term would be term 0, which doesn't make any sense. So n being 1 here doesn't work. So it's only for the second term and above. That's what this means. Okay, so going on with that. So writing a recursive formula is pretty easy, right? You just figure out what the common difference is. So you would take a term and subtract the previous term. So -7 minus -18 is 11. So we're adding 11 each time. And then my formula is just that each term is the previous term plus 11. And don't forget to state your first term. You always have to state your first term when you're writing a recursive formula, because I can't use this formula without the previous term. So without this here, it would be incomplete. It would be an incomplete answer, so that's not good. And again, it's going to be a straight line if it's arithmetic. That just is how that works. Okay. So that's recursive. So, yeah, pretty straightforward. Again, with explicit formulas, you can find any term if you have the formula. With what's the word I'm looking for? With recursive formulas, you can only find the next term. So you can find any term or you can find the next term. So that's any term with explicit, just the next term with recursive. So that's the difference. Yeah, give me a second. Yes, finite arithmetic sequences. So if you're given something that is finite, so we have a starting term and we have an ending term. This thing ends. So we want to figure out in this one how many terms we're going to end up having, because we just have this ... here. We don't know how many terms we're going to have. We could write out the whole thing, but what if we have 100 terms? So let's not do that. Let's be smarter than that. First, we're going to figure out what our common difference is. So 1 minus 8 is -7. So that's our common difference. We know that our formula is going to be an equals the first term plus dn minus 1. We want to find n for our final term because we want to know how many terms are in our sequence. We want to find n where an is the final term. So we're going to just do that. We're going to plug in the first term here, and we're going to plug in the last term here. Actually, they already simplified this side. Sorry. First term here, last term here, and then they went ahead and simplified this. Obviously, this is d. This is the common difference. So first term, common difference, and then they simplified. So they distributed that. So they got -7n plus 7. And then 8 plus 7 is 15. So 15 minus 7n is just the simplified version of this. And then they said, okay, I know that my last term is -41. So I'm going to plug that in over here to see what n I get. And they solved that, and they got that n equals 8. So we're really just still using the same formula, using the information that we know to find the information that we're looking for. So this sequence is going to have 8 terms in it. And if we have the first and last term and the common difference, then we can find that. Or if we have a couple terms at the beginning, find the common difference. And then if we have the last term and the first term, then we can find the number of terms. So that's what happens when you have a finite sequence. Okay. All right, I think that's all. Yeah, that's all I have to talk about on this section. Hopefully pretty straightforward. Let me know if you have any questions, and I will see you in the next video.